Genius Kids. Cultivating love for learning.
Chapter 9. Pressure and Force. Knowledge acquisition. Force is any influence that causes some object to move. Pressure is the force per unit area applied perpendicularly to the surface of the object. Force comes into action by interaction of objects. SI unit for measurement of force is Newton, N. Discussion. Jack. Wow, today I will just play. Susie. Hi Jack. Jack. You, again please don't say anything today. I have planned to play today. Susie. Oh no, not at all, I will disturb you. By the way, what are you doing? Jack. Can't you see, I am playing hockey. Susie. No, you are applying the force on your hockey stick so that it can move the ball in the direction you wish. Jack. Chapter number 10, Force and Pressure. Yes, I have read it. Susie. What, without me? Jack. Yes, you always ask me something at the beginning of the chapter. Today you go and read the chapter along with the students. By time, I will apply force on my football and bat in the playground. Force. Definition. Any influence that can cause motion or move some object is called as force. Interaction of objects and force. Until and unless the body applying the force does not interact with the body that needs to be moved on, force will not act or motion will not occur. For example, exceptions. Exceptions include non-contact force. An example of a non-contact force is a magnetic force. Magnetic force does not require the two bodies to interact with each other. Magnet can pull the iron nails even without touching. Resultant force. Total amount of force acting on an object is equal to the resultant force. For example, if a cupboard is pushed by three individuals, namely A, B and C, and the amount of force applied by each is F1, F2 and F3 respectively, then the resultant force will be F is equal to F1 plus F2 plus F3. But if another person D applies the force F4 on the same almirah in opposite direction, then the resultant force is F is equal to F1 plus F2 plus F3 minus F4. If the force acting in opposite direction is equal to other applied force, then resultant force is equal to 0. For example, if F1 and F2 are the two forces acting in opposite direction and F1 is equal to F2, then resultant force is equal to F1 minus F2 is equal to 0. Magnitude, direction and unit of force. Magnitude of a force is its strength and it is measured in Newton, N. Force required to lift a body of 100 grams in vertical direction perpendicular to its surface is equal to 1 N. Critical thinking. It takes 8 minutes 17 seconds for light to travel from the sun's surface to the earth. Force always has direction of its action. As seen in the last section, forces acting in the same direction are added up and those acting in the opposite direction would be subtracted. Effects of force. Force can generate the following effects. 1. Change of direction of a moving object. 2. Can make the moving object move faster. 3. Can make the moving object move slower. 4. Can change the size of some object. 5. Can change the shape of some object. Types of force. On the basis of interaction between any two objects, there are two types of the force. A. Contact force. This kind of force comes into play when an object interacts with another object directly by touching it. 1. Muscular force. Force generated by muscular action is a type of muscular force. For example, writing, eating, pulling of bullock cart, etc. Different types of contact force include the following. 2. Frictional force. Force that can cause a change in state of motion is called as frictional force. Frictional force is the force that acts in a direction opposite to that of motion. Examples of frictional force include: on a carom board, striker comes to rest by itself. Bus stops by itself when brakes are applied. Ball stops itself on the ground after traveling a little distance. Frictional force always acts between two surfaces, surface of the object in motion, and the surface on which it moves. B. Non-contact forces. These forces come into play even when the objects are not in contact. Different types of non-contact force include the following. 1. Magnetic force. Forces exerted by a magnet is called magnetic force. For example, iron nails are attracted by a magnet. 2. Electrostatic forces. Forces between charged particles are called electrostatic forces. Like charges repel each other, and unlike charges attract each other. 3. Gravitational force. The force that is responsible for pulling an object towards the earth is called as gravitational force. For example, we do not fly but stand on the earth due to the gravitational force. Pressure. Definition: force per unit area exerted vertically on the surface of an object is called pressure. Pressure is denoted by P. Pressure is equal to force upon area, or P is equal to F upon A. Pressure is directly proportional to force and inversely proportional to the area. This means, more the area, less will be the pressure, and more the force, higher will be the pressure. SI unit for measurement of pressure is nm2 or 1 Pascal in honor of Blaise Pascal. Numericals. 1. Calculate the pressure produced by a force of 800 N on an area of 2 m square. Solution: pressure is equal to force upon area. Force is equal to 800 N. Area is equal to 2 m square. Pressure, P, is equal to force upon area. 800 upon 2 is equal to 400 pascals. 2. Calculate the pressure exerted by a box resting on a table. The box applies a force of 4.2 N when A. It is made to stand on the table. B. When it is placed on its widest base. The dimensions of the box are 30 cm into 10 cm into 5 cm. Solution: A. When the box is made to stand, area in contact with the table is equal to 10 cm into 5 cm is equal to 10 upon 100 into 5 upon 100 m is equal to 0.005 m square. Pressure exerted is equal to F upon A is equal to 4.2 N upon 0.005 m square is equal to 840 pascals. In CGS system, the unit of pressure is dyne cm2. Pressure exerted by solids. Pressure exerted by a solid depends on its area of action. More the area, less will be the pressure, and vice versa. Examples include: case where less pressure is desired. In footwears, in the case of broader heel, pressure exerted is less as compared to tip-toed heel. Some cases where more pressure is desired. Bursting of a balloon is easy by a pin as compared to finger, because in the case of a pin area is less and pressure is more. Solids have definite shapes, so pressure is exerted only on area where force is acted upon it. Everyday examples. So, now you can very well understand why the cutting edges of tools like blades, knives, axes are made sharp and why pins and needles have sharp points. However, in some cases, it is required to reduce the pressure as well. Try walking on sand or snow wearing your stilettos. It would be very difficult and almost impossible to walk. This is because all your body weight exerts pressure on a very small surface area, due to which the pressure increases tremendously. That is why camels have broad feet, as this reduces the pressure exerted on sand and hence they are able to walk easily on sand. For the very same reason, skis are always made long and flat, which increases the area in contact with snow. So, now can you guess why it hurts to walk over stones and gravels, and why porters while carrying load place a roll of cloth on their head? Pressure exerted by liquids. Liquids do not have a specific shape, they take the shape of the vessel in which they are poured. Pressure exerted by liquids depends on their density and height of the liquid column. Liquids exert pressure on all the surfaces of the vessel containing it, unlike solids, which exert pressure on the area on which force is acted upon. Let us design some activities to prove that all the facts mentioned above are correct. Manometer. It is a device which is used for the measurement of pressure. Manometer consists of a U-shaped glass tube that is filled with liquid mercury because its density is high. The two ends of glass tube are open and the 2 points A and B, as shown in the figure, are at same vertical height and atmospheric pressure. One end of the U-tube, say A, is left free, whereas end B is connected to a flexible tube that is, in turn, connected with the point where the pressure inside the liquid needs to be measured. The pressure is measured with the help of difference in height of liquid column in a U-shaped tube. Pressure exerted by gases. Gases also exert pressure. Just like a liquid, gases too exert pressure in all the directions. Pressure exerted by gases is equal in all the directions of a container which contains it. Critical thinking. Deep-sea fishes do not prefer to come to surface of water because blood in their body flows with a very high pressure, and pressure at surface of sea is less, so it can result in the bursting out of their body if they try to swim at the surface of sea. Atmospheric pressure. Atmosphere is a gaseous mixture surrounding the Earth. Atmosphere is retained by gravitational pull. Different gases have the power to exert pressure. Pressure exerted on the surface of the Earth by the mixture of gases of atmosphere is called atmospheric pressure. Now, as we know, pressure is equal to force per unit area. So, atmospheric pressure is the pressure exerted by the atmosphere air on the Earth's surface per unit area. 1 unit of atmospheric pressure is a very huge pressure, and it has the power to crush almost anything. Critical thinking. Barometer is the device used for measurement of atmospheric pressure. At higher altitude, nose of some people starts to bleed because pressure in their body becomes higher at high altitude, as a result of which their blood vessels burst open. The same reason is applicable to learning of fountain pen at higher altitudes. Continuous review. Any influence that can cause motion or move an object is called force. Total force acting on the object is equal to the resultant force. Force can change the direction, size and shape of the moving object. Force can be a contact or non-contact force. Force per unit area exerted vertically on the surface of the object is called pressure. Pressure is exerted by solids and fluids.
like, share, and subscribe.